Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, I will be going through trigonometry ratios, right? And trig ratios play a big role in trigonometry. Why am I saying this, right? For example, trig ratios can be within a trigonometry question that asks you to solve compound angle equations. Trig ratios can be in a question that asks you to find the general solution, right? So trig ratios form the foundation of trigonometry, and if you don't understand your trig ratios, then you will struggle tremendously with analyzing most of the trigonometry questions, right? So if you're struggling with trig ratios, please make sure that you watch this whole video, right? Because I'll be explaining to you what are trig ratios. I'll be explaining what trig ratios are and how trig ratios are defined when you have a right angle triangle. I will be showing you how trig ratios are defined on the Cartesian plane, right? And I will also be taking you guys through 4 examples to help you with your application of your trig ratios, right? And in these 4 examples, guys, we'll be making use of a sketch, okay, to help us understand what exactly is going on in the 4 quadrants, right? Before we get started with the video tutorial, guys, please make sure that you are subscribed to the channel. Please like this video, and also please make sure that you click on the notification bell so that you get notified every time I upload a new video. And guys, please also make sure that you share this channel with your friends. Okay, so enough with the chit chat, guys. Let's get started with the video tutorial. So guys, what are trig ratios? Okay, guys, trigonometry ratios are defined as the values of all trig functions based on the value of the ratio of the sides of a right angle triangle with respect to any of the triangles acute angles, right? So what do I mean by acute angles? I mean angles that are less than 90 degrees, right? So for example, what does this definition mean, right? So if you were asked to find or define the trig ratios of this triangle with respect to theta, right? This angle theta, right? If you were to find the sine of theta, the sine of theta would be the opposite side over the hypotenuse, right? What is the hypotenuse? The hypotenuse is the side that is opposite your 90-degree angle, right? What would the cos of theta be, right? It would be for this triangle, right? So the cos of theta would be the adjacent side over your hypotenuse. What is the adjacent side? The adjacent side is the side that is next to the angle that you are working with, or the reference angle that you're working with, right? So then in this regard, or in this situation, our adjacent side to our theta would be our BC. So that is the side that is next to our theta and your hypotenuse. So cos of theta is your adjacent over your hypotenuse, right? And what is your tan of theta? Tan of theta is defined as the opposite over your adjacent, right? So the opposite side is the side AC over your adjacent side, which is the side next to our angle theta, and that is our side BC, right? So let us just write this down in terms of AC, BC, and AB. Okay, so we said that the sine of theta is the opposite over the hypotenuse. So the opposite side is our side AC, right? And our hypotenuse is our AB, right? What is the cos of our theta, right? We said the cos of theta is your adjacent side, which is your BC, over your hypotenuse, which is your AB, right? And what would the tan of our theta be? The tan of the theta will be then the opposite side, which is the AC, over the adjacent side, which is your BC. That is how we define our trig ratios, right? And guys, what is important to remember when you're working with trig ratios? You work with trig ratios, right, when you're able to apply trig ratios when you're working with a right angled triangle, right? Another way to help you remember how you define your trig ratios is by using the word SOHCAHTOA, right? So it's SOHCAHTOA, right? So this helps us remember that means that the sine of your angle is the opposite of a hypotenuse, right? The cos of the angle is your adjacent A for adjacent, H for hypotenuse, right? Adjacent over your hypotenuse, and the tan of your theta or tan of your angle will then be your opposite over your adjacent. Okay, so now let us look at a quick example, right? So if you are given a following triangle and you are asked to find the trig ratios for this triangle with respect to theta, how would you find these trig ratios, right? We said that to help us define our trig ratios, we need to use SOHCAHTOA, right? Meaning that the sine of our angle theta will be your opposite over your hypotenuse. Your cos of your angle theta will be your adjacent over your hypotenuse. And your tan of your theta will be your opposite over your adjacent. Right? But then guys, I'm sure you guys have noticed that there is something missing from this triangle, right? We've got two sides of this triangle. We've got the opposite side with respect to our angle theta, and the opposite side is 4. We have our adjacent side with respect to our angle theta, and that adjacent side is 5. But we are missing the hypotenuse. So how do we get the hypotenuse, right? When we define sine of theta, we say opposite of our hypotenuse, right? When you define your cos of theta, we say adjacent over hypotenuse, right? And when we define your tan of theta, we say your opposite over adjacent. So guys, we really need the hypotenuse. So how do we calculate your hypotenuse, right? Guys, the hypotenuse, if you have a right angle triangle, and you've got two sides, right? You are able to calculate the hypotenuse by using the theorem of Pythagoras. Okay, so by using the theorem of Pythagoras, right, we will be able to calculate our hypotenuse, right? So let me just name my triangle as triangle A, B, and C, right? So what does the theorem of Pythagoras say, right? The theorem of Pythagoras says that the hypotenuse squared is equal to your x squared plus your y squared. Okay, so what is our x squared? It's our BC squared. Plus what is your y squared? Is your AB squared, right? So we're just going to quickly substitute the values for your BC and your AB. Your BC is 5 squared plus your AB is your 4 squared. Okay, so to find your AC, we're going to square root both sides. Okay, to cancel out the square root, you can just square root both sides, right? And then you'll find that your AC is equal to the square root of 41. Right? So now that we've calculated our hypotenuse, guys, we can simply define our trig ratios, right? And like I mentioned, guys, sine of theta is equal to right? So it's opposite over your hypotenuse. What is the opposite side? The opposite side is your 4. And what is your hypotenuse? It is the square root of 41. Okay, what is the cos of theta? We mentioned that the cos of theta is k, right? So it's adjacent over hypotenuse. So it's adjacent over your hypotenuse, right? So what is the adjacent side? The adjacent side to our theta, or the side that is next to our theta, is the 5. Okay, and what is our hypotenuse? Your hypotenuse is the 41. Square root of 41. Okay, let us define our tan of theta. Tan of theta, guys, it is opposite over adjacent. So it's opposite over adjacent, right? So what is our opposite side? Your opposite side, right? The side that is opposite our theta is 4, and our adjacent, or the side that is next to theta, is 5, right? So we've basically defined our trig ratios, right, with respect to theta, or we've defined our trig ratios by using theta as our reference angle. So now what happens if we are asked to define our trig ratios, right, and we now have an angle alpha? So we need to define our trig ratios in terms of alpha, right? So I just made a silly mistake. This is actually supposed to be alpha. Okay, so like I mentioned, guys, I just made a silly mistake. I was supposed to write sine alpha, cos alpha, tan of alpha, but I had sine theta, cos theta, tan of theta. But it's fine, we've just fixed that mistake, right? So now if we have to define our trig ratios in terms of alpha, how would we define the trig ratios, right? And then again, guys, remember, you need to remember SOHCAHTOA, right? Which reminds us that sine of theta is equal to your opposite over your hypotenuse, cos of theta adjacent over hypotenuse, and then your tan of theta is your opposite over your adjacent, right? But then, guys, what do we notice here? We've got a side that is missing, right? So our opposite side to our angle alpha is missing, right? So how do we get the opposite side? If we were to label this triangle as triangle A, B, and C, right, we know that using the theorem of Pythagoras, says that the hypotenuse, which is your AB, right, squared, and I mentioned that, guys, the hypotenuse is the side that is opposite your 90-degree angle. So the theorem of Pythagoras says that your hypotenuse squared is equal to your x squared, which is your AC squared, plus your y squared, which is your BC squared, right? So we're simply going to substitute all the values into this formula. What is our AB squared? We know that our AB squared is 7, so it's 7 squared, plus what is your AC? Your AC is 6 squared. And what is your BC? We are looking for your BC, right? So from here, what do? You basically make your BC the subject of the formula, or you just isolate your BC, right? All right, so you'll find that your BC is equal to 7 squared minus your 6 squared is equal to your BC squared, right? And if you square both sides, or you square root both sides, you'll find that the square root BC is equal to the square root of 7 squared minus 6 squared, which is equal to the square root of 13, right? So the BC is equal to the square root of 13. Okay, so now we can define our trig ratios, right, using alpha as our reference angle, right? Sine of alpha is opposite over your hypotenuse, so your opposite side is square root 13, and your hypotenuse is 7, right? Cos of alpha is your adjacent over your hypotenuse. Your adjacent side is 6 over your hypotenuse is 7. And tan of alpha is equal to opposite over your adjacent. So your opposite side to our angle alpha is square root 13. And the adjacent is 6. Okay, so we've basically now defined the trig ratios with respect to our angle alpha. So now let us have a look at what happens, or how we define our trig ratios on our Cartesian plane, right? Let us start off by labeling our Cartesian plane. Firstly, guys, right, this is the x-axis, this is the positive x-axis, this is the positive y-axis, right? This is the negative x-axis, and this is the negative y-axis, right? This is the 0 degrees, okay? And if your theta angle moves from 0 to up there, that is 90 degrees. Your theta angle continues to move from 90, and we add another 90, that is 180 degrees. From 180 plus 90, it's 270 degrees. 270 plus 90 is equal to 360 degrees. So another thing that I've basically included on our Cartesian plane is this circle, right? So I've basically imposed or drawn a circle on our Cartesian plane, right, to help us define our trig ratios. Let's just have a look. If I were to draw a line from the center of the circle to a point on the circle, what would the coordinates of this point be, right? So let's draw that line and see, right? So I've drawn a line from the center of the circle to a point on the circle, right? We'll call that point A. And then we draw another line from the point A going down to the x-axis, okay? From here, guys, what do we see? We see that we do have a right angle triangle, right? And then from here, guys, how would we get the coordinates of our point A, right? So what would the x coordinate be for A? What would the y coordinate be for A, right? So the x coordinate would be 2, right? And the y coordinate would be 2. Okay, so from here, guys, we've got the x coordinates, we've got the y coordinates, but why am I calculating the y coordinates? Why am I calculating getting the x coordinates, right? I'm trying to help you see that, guys, because I've drawn a line from the center going to a point on the circle, right? We want to call that line OA. That line can also be called our radius, right? So line OA can also be called the radius of our circle, right? And what do we know about the radius of our circle? The radius of our circle remains constant, right? So the radius that we get from here to here is going to be the same as the radius that we get from there to there. It's going to be the same as the radius that we get from there to there. It's going to be the same as the radius that we get from there to there. It's going to be the same as it doesn't change. Your radius remains constant throughout your whole circle, right? And that is very important for you guys to remember when you're working with trig ratios, especially on the Cartesian plane, right? The r, it doesn't change. It stays the same, right? The r is always positive as well, right? So it remains the same. And from here, guys, we don't even have to calculate, right? But our r for this question is supposed to be 3 if I basically drew my diagram correctly to scale, right? Remember, by using the theorem of Pythagoras, we are able to calculate the value of r, right? And the theorem of Pythagoras says that, right, your r squared, I'm going to do it up here, r squared is equal to your x squared plus your y squared, right? So what is our x squared? We found that your x squared, guys, is your 2 all squared, plus we found that your y squared is also 2 all squared, right? So if you punch that into your calculator, you'll find that your r squared is, your radius or your OA is equal to 2 square root 2, right? Which is approximately equal to 3, but it's 2.83. Right? So it's close to 3. I haven't drawn my diagram to scale, but it's okay. It's not a train smash, right? So that's fine, guys, right? So we found that your radius for this circle is equal to 2 square root 2, right? So I'm going to write that down here. Okay, so how will this help us with anything, right? Guys, what we see now is that when we are working with trig ratios on our Cartesian plane, right, the trig ratios will be defined in terms of x and y, right? For example, if we call this our angle theta, right? And guys, you also need to remember when you are working on your Cartesian plane and you're dealing with positive angles, you always move in an anti-clockwise direction, right? So from the positive x-axis and you move in that direction, right? You only move in a clockwise direction when you're dealing with negative angles. But for now, right, we're dealing with positive angles, so you're going to move in an anti-clockwise direction. So the angle theta is measured from the positive x-axis and it goes in that direction, right? So if we call that angle our angle theta, okay, what would then be the sine of theta. What would then be the cos of theta? And what would then be the tan of theta? Right? Remember, I told you guys that when you're working with trig ratios, it's good to remember SOHCAHTOA. SOHCAHTOA. Right? Because that reminds you that the sine of theta is equal to your opposite over hypotenuse. Your tan of theta is equal to your adjacent over your hypotenuse. And your cos of theta is equal to your adjacent over your hypotenuse. And your tan of theta is equal to your opposite over your adjacent, right? But then when we want to define our trig ratios on our Cartesian plane, it's always good to always define them in terms of x and y, because that also helps us when we're working with when we're applying trig ratios in questions that ask us to work with an aid of a diagram to answer our questions, right? So for example, right, the opposite of theta, right, is also known as your y, and your adjacent of theta, the side that is next to our theta, is also known as your x. Okay, and your radius or your line OA is known as your radius, right? So sine of theta is also known as your y over your r. Cos of theta, right, is your adjacent over hypotenuse, so it's your x over your r. And your tan of theta is also known as your opposite, which is your y, over your adjacent, which is your x. All right. Okay guys, so let us have a look at why we are taught that in the first quadrant, right? So let's just label our quadrants. This is our first quadrant, and they use Roman numerals to label our quadrants, right? So this is our first quadrant, this is our second quadrant, this is our third quadrant, and this is our fourth quadrant, right? We are told that in the first quadrant, all of the trig ratios are positive, right? We are taught that in the second quadrant, only the sine ratio is positive. We are taught that in the third quadrant, only the tan ratio is positive, and we're also taught that in the fourth quadrant, only the cos ratio is positive. But why is this? Why are we taught that all ratios are positive in the first quadrant, only the sine is positive in the second quadrant, and tan is positive in the third quadrant, and cos is positive in the fourth quadrant, right? So by defining our trig ratios in terms of y and x, right, we are able to also see why the ratios are positive in the first quadrant. Let's just have a look in the first quadrant, right? Do you agree that in the first quadrant, we are working in the quadrant that has your x values that are positive and your y values that are positive, right? Meaning that your y is positive, right? So the sine is positive in this quadrant, right? Your cos, the x is positive, right? So the cos is positive in this quadrant, right? And with your tan, both the y and the x are positive, right? Okay. In this quadrant, the y is positive and the x is positive, right? Therefore, that is why they say that all the trig ratios are positive in this quadrant. Let's have a look at this quadrant, okay? So if we looked at this second quadrant, guys, we would measure our angle theta, right, from the positive x-axis all the way to that line there, right? So that would be our angle theta, right? So in this quadrant, guys, what happens, right? We know that sine of theta is still y over r, right? We know that cos of theta is still x over r. And you know that tan of theta is still y over x, right? So now what happens in this quadrant? What do we notice about this quadrant, right? In this quadrant, guys, we notice that your x values are negative, right? Because we are in the negative, we are working on the negative x-axis side, right? So our x values will be negative, right? But your y values will be positive on this quadrant. So on our second quadrant, y is positive but x is negative, right? So what does that mean, right? It means that the y sine of theta is positive because your y is positive, right? I have to reiterate this point, guys. Your r remains constant, right? It remains constant. The r value will always be a positive 2 square root 2. It doesn't change. It remains as a positive. That is why we just leave it like that. But the values that keep changing is the values of your y as well as your x, right? Let us have a look at our x. We see that in this quadrant, your x is negative, right? So the cos of theta is negative, right? Negative x over r. So what do we see here? Cos of theta is negative on this quadrant, right? And let's have a look at tan of theta. Tan of theta is equal to y over x. And what do we know about the x values? The x values on this quadrant are negative, right? So the tan of theta in this quadrant is negative. So that's why we get told that in this quadrant, only the sine of theta is positive. Okay, let's have a look at our third quadrant. Okay, so what is our sine of our theta? Sine of theta is always y over r, right? So cos of theta is always x over r, and tan of theta is always y over x. Okay, so let us see. Since we are in the third quadrant, what is happening with our x values? Our x values are negative and our y values are also negative, right? So then the sine of theta will be negative y over r. The cos of theta will be negative x over r. But the tan of theta will be negative y over negative x, which is ultimately positive y over x. So that is why on this quadrant your tan is positive, right? And lastly, let us have a look at our fourth quadrant. In our fourth quadrant, you still have sine of theta, cos of theta, and your tan of theta, right? Sine of theta is y over r, cos of theta is x over r, and your tan of theta is equal to y over x, right? Let's have a look at the values of the y as well as x on this quadrant, right? On this quadrant, the x is positive, however, the y is negative, right? So sine of theta will be negative y over r. The cos of theta will be positive x, right? Because the x is positive. X values are positive on this quadrant. Positive x over r, and the tan of theta will be negative y over x, right? So then that is why we are taught that in this fourth quadrant only the trig ratio cos of theta is positive. Okay, I also just want to show you guys how you would measure the angle theta when you're working in the third quadrant. Okay, so to measure your angle theta for when you're working on the third quadrant, okay, you would start from the positive x-axis and move all in an anti-clockwise direction to your third quadrant, right? And how would you now measure your angle theta on your fourth quadrant? You would still start on the positive x-axis, move in an anti-clockwise direction to your line, and that would be your angle theta, guys. So guys, these basics are very, very, very crucial when you're working with ratios, because if you don't understand these basics, it will really be a struggle when you have to now apply your knowledge for working with questions that involve ratios as well as making use of a sketch. Okay, so guys, I feel like I've basically explained everything, right? In terms of how your trig ratios are defined when you just have a normal triangle, a normal right angle triangle. And I've also explained how your trig ratios are now defined when you're working in a Cartesian plane, right? I explained why we are taught that all the trig ratios are positive in the first quadrant. I explained why only the sine ratio is positive on this quadrant. I explained why only the tan ratio is positive on this quadrant, and I also explained why the cos ratio is positive on this quadrant, right? And then guys, there's something that is also very important that you guys need to be able to to understand when you are working on the Cartesian plane, right? This diagram is starting to look very busy. It's starting to look very detailed, but we have to basically disclose all of this information because it will be very important, like I mentioned, when you're working with ratios, when you're working with reduction formulas, right? When you're working with the general solution, you need to know all of this information, and you also need to be able to apply it to work through your problems, okay? So like I said, guys, what happens? So we're going to just be focusing on the last bit of information for when you're working with when you're working on your Cartesian plane, right? Guys, but less than 90 degrees, okay? Okay, so then guys, there's also something that is very important that you guys need to see that is going on in these 4 quadrants, right? Looking at the first quadrant, right? Do you guys agree that in the first quadrant, your angle theta, right? Or the angle that is, or any angle that is in this quadrant will always be obviously either equal to 0, right? Or greater than 0, but less than 90 or equal to 90. Right? Okay, when you look at our second quadrant, any angle that is in this quadrant will either be equal to 90, right, or greater than 90, right, or equal to 180, but less than 180, right? Let's have a look at the third quadrant. Do we agree that any angle that is in this quadrant will either be equal to 190 or greater than 190 or equal to 270 or less than 270, right? And let us have a look at this quadrant. Do you also agree that any angle that is in this quadrant, right, will be equal to 270 or greater than 270 or equal to 360 or less than 360? Okay, so how would we write this? Okay, so like I mentioned, in the first quadrant, right, your angle theta will always be greater than or equal to 0 degrees, but less than or equal to 90 degrees. Okay, the angle that is in the second quadrant, right, the angle theta, if we're working with our angle theta, will always be greater than or equal to 90 degrees or less than and equal to 180 degrees. The angle that is in the third quadrant, or if we had an angle theta on the third quadrant, okay, that angle would be on the interval of greater than or equal to 180 degrees or less than or equal to 270 degrees. Okay, and lastly, let us have a look at the fourth quadrant. If you have angle theta on the fourth quadrant, that angle will be always greater than and equal to 270 degrees or less than and equal to 360 degrees. Okay, so like I mentioned, angle theta on this quadrant. All right, so then guys, how will this help us with anything? Right, guys, I'm sure you guys know that obviously when you're working with trig, you also work with reduction formula, right? And since we mentioned that when you're in the first quadrant, right, the angles that are in the first quadrant are always greater than or equal to 0, but less than and equal to 90 degrees, right? So this quadrant can also be called the 90 minus theta quadrant, right? Because you've got angles that are less than 90 degrees but greater than 0 degrees, right? This quadrant can be called the 180 minus theta quadrant, right? Because you've got angles that are less than 180 but greater than 90, right? So it can also be called the 90 plus theta quadrant, right? Okay, let's have a look at the third quadrant. Okay, so in the third quadrant, like I mentioned, you've got angles that are greater than 180 but less than 270, right? So that means that this quadrant can also be called the 180 plus theta quadrant, right? Or the 270 minus theta quadrant, right? And let's look at the fourth quadrant, right? Like I mentioned, we've got angles that are greater than 270, greater than or equal to 270, or less than and equal to 360, right? So this can also be called the 360 minus theta quadrant, or the 270 plus theta quadrant. Okay, guys, this information that I've just given to you guys is very, very important in trig. I've basically given you guys the foundation, the core of trigonometry, right? So if you are able to, if you understood every single detail that I've gone through with you guys today, then you are ready for trig. You are ready to start building your house, right? Because we've now laid the foundation, right? And now we can start building from that foundation, and we're able to build a solid and a strong house, right? Okay, I think I'm gonna wrap this video up here for today. Like I mentioned, guys, I wanted to go through examples with you guys, but I'm afraid this video is going to be too long, right? But I will be uploading this next video tutorial shortly, so just make sure that you just hit the notification bell if you want to follow with me as I build on our trigonometry concepts, right? I've basically covered all the basics that you guys need to know for trigonometry. I've covered what you guys did if you are a grade 12 learner. I've covered what you guys did in grade 11, right? And I've covered it in detail, right? So if you took down notes of everything that I did today, then you're ready to start working with me and going through example 1. You can just quickly for now copy down this question, try it on your own, right? And then when I upload the next video, which is literally the next day after, then you'll be able to follow with me as I go through this question, right? I hope you guys enjoyed this video tutorial. I hope I just cleared out some questions probably that you had in terms of the trig ratios on your Cartesian plane, as well as just working with trig ratios when you just have a regular or just a right angle triangle, right, guys? I hope you guys enjoyed this video tutorial, guys. Please don't forget to give this video a huge thumbs up, all right, because that really helps the channel. Next video tutorial, guys, we're going to be going through question 1, and question 1 is basically trig ratios using the aid of a diagram, right? Please make sure that you are subscribed, and also please make sure that you click the notification bell so that you get notified when this question comes up. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.